Hello and welcome to Data Analysis and Statistical Inference Lab. My name is Asim Amjad. Statistics is defined as the field that focuses on turning the information into knowledge. The first step in that process is to summarize and describe the raw information like data. In this video, you will gain insights into public health by generating simple graphical and numerical summaries of a dataset collected by the Centers for Disease Control and Prevention. Okay, let's start the video. The Behavioral Risk Factor Surveillance System is an annual telephone survey of 350,000 people in the United States. As its name implies, the BRFSS is designed to identify risk factors in the adult population and report emerging health trends. For example, respondents are asked about their diet and weekly physical activity, possible tobacco use, and even their level of health care coverage. So, we will focus on a random sample of 20,000 people from the BRFXX survey conducted in 2000. While there are over 200 variables in this dataset, but we will work with a small subset. We will begin our first lab by loading the dataset of 20,000 observations into the R workspace. So first of all, open the R Studio. Here we have it. And after launching the R Studio, enter the following command to access the dataset. After typing the command, simply press the enter key. Now R language is start loading the dataset. It will take some time to load all the data into R language. If you click this button, then you will see the data matrix if it is not showing automatically. The dataset CDC that shows up in your workspace is a data matrix with each row representing the case and each column representing the variable. Our language calls this data frame. In the first part of Lab 1, we will focus the following R commands that are named as names, head, tail, summary, mean, variance, median, table, and bar plot. Okay, let's start with the first command, that is names. Actually, the name command is used to view the names of the variable. Now I'm start typing that command, that is names. Now I have to add the table name to view the names of the variable, and the name of the table in this case is CDC as shown here. Press the enter key and now you can see on your screen the names command returns the name of variables of the table CDC. Actually, each one of these variables correspond to a question that was asked in the survey. For example, the first variable, respondents were asked to evaluate their general health responding either excellent, good, very good, fair, or poor. Similarly, the second variable indicates whether the respondent exercised in the past month or did not. One mean he did the exercise and 0 mean he did not did the exercise. Okay, let's do the exercise 1, that is how many cases are there in this data set and how many variables for each variable identify each data type. We can view the first few entries of our data with the command head. So I'm typing the command that is head, and Now I have to add the table name, that is CDC, and press the enter key. Okay, so now you can see using the head command, I can see the top few entries of the table, as well as if I'm using the tail command, enter the table name and press the enter key, then I can view the last few entries of the table. So from using these two commands, we can look the data frame from start or from bottom, and we know that the total number of rows are 20,000. You can see here and here. So, viewing the entire dataset would mean flooding your screen. It's better to take small parts at the data with head and tail command, or using the subsetting techniques that you will learn in a moment. Okay, up till now we have discussed the name, head and tail command. Okay, now let's discuss the summary command. Okay, now I'm typing the summary command under the console menu, and after typing the summary command, I have to write it down the name of the table that I want to look at the summary statistics. So I'm typing the name of the table, that is CDC, and press the enter key, and after pressing the enter key you can see the numerical summary, which include minimum, first quantile, median, mean, third quantile, and the maximum value for each of the variables of the table named CDC. But the first and the last variable shows the number count, because the first variable and the last variable data values are descriptive in nature, as well as the last variable named as gender shows the number count of male and female. You can clearly see from the above CDC window, the first variable and the last variable are the descriptive in nature, but remaining table columns are include the numeric values. That's why these two variables only show the number count, and the rest columns show the summary statistics values. What if I want to see the numerical values of the weight column only? Then you have to again use the summary command. But the summary command, you have to specify the column name of the table that you want to see the summary statistics value. So in this case, I am typing the summary command again, and now I have to write it down the table name and put a dollar sign to indicate the column of that table, that is the weight, and press the enter key, and you will see the minimum, first quantile, medium, mean, third quantile, and maximum value of the weight column only of the CDC table dataset. You can also use the R language as a functions like a very fancy calculator. If you want to compute the interquartile range for the respondent's weight, you would look at the output from the summary command above and then enter the 190 minus 140 and press the enter key, and you will get the result, that is 50, which is showing the interquartile range of the dataset of weight column only. So I'm simply typing here a 190 value and minus this first quartile value, that is 140, and I will get the answer, that is 50. R language also has built-in function to compute the summary statistics one by one, for instance to calculate the mean, median and variance of the weight type. So let's type mean and now type the table name, that is CDC. Now for mentioning the column of that table, I have to substitute or put a dollar sign, and then I have to select, or I can also type it here, the weight that is the name of the column. Press the enter key and you will get the mean value of the weight, and here you will also get the mean value. If you want to compute the variance, type VAR and then again substitute or type the table name and then add a dollar sign and then type the weight and press the enter key and you will get the variance of that table. And for calculating the median of the table, type median and now add the table name, put a dollar sign for selecting the right column, that is weight, and press enter key and you will get the median of that column range. Now it makes sense to describe a quantitative variable like weight in terms of these statistics measures. But what about the categorical data? Instead, we consider the sample frequency or relative frequency distribution. The table function actually does this thing for us by counting the number of times each kind of response was taken. For example, to see the number of people who have smoked 100 cigarettes in their lifetime, you have to type the table function like this and then add its argument, that is table name CDC, that is actually the name of the table, and put a dollar sign and then select the column name, that is smoked 100, and press the enter key and you will see the total number count of the people who have smoked 100 cigarettes in their lifespan. 0 means these are the statistics values that have never smoked 100 cigarettes in their lifespan. But these statistics values are showing that these number of people have smoked 100 cigarettes in their lifespan. To find out the relative frequency distribution, you have to simply divide this term by 20,000 and you will get the percentage of the persons who haven't smoked 100 cigarettes in their lifetimes and the percentage of those persons who have smoked 100 cigarettes in their lifetimes. So you can use the upper arrow key to repeat the previous command that you use in the R language, and now I'm putting the division symbol and type it here 20,000, that is actually the total data set of the CDC table, and press the enter key and you will get the relative frequency of the persons who have smoked 100 cigarettes and who haven't smoked 100 cigarettes in their lifetime. 0 means haven't smoked 100 cigarettes in their lifetime and 1 means smoked 100 cigarettes in their lifetime. So these two relative frequency values describe here that 52.795% are the people who haven't smoked 100 cigarettes in their lifetime, but 47.205% people have smoked 100 cigarettes in their lifetime span. So now you may notice how R automatically divides all the entries in the table by 20,000 in the command above. Okay, now it's time to make a bar plot of the entries in the table. So by putting the table inside the bar plot command, so type bar plot and now you have to type the table command and now add the table name, put a dollar sign and select the column name, that is smart 100, and press the enter key, and on the right hand side you can see the bar plot. So now you may have noticed that we have computed the table of CDC dollar smart 100 and then immediately use this function as the bar plot command. So this is an important idea that R command can be nested. You can also break this into two steps by typing the following command. Smart, put special symbol less than, minus, and then type the table command, add the table name, put a dollar sign to select the right column, and then press the enter key. And now type again barplot command, and now under the barplot command type smart variable name, instead typing the table command, and press the enter key and you will get the same result. Okay, now you can see I have put it here a new variable name, that is smart, and then I assign this smart variable to this function using this special character that is used as an assignment operator, and then I use this term into the bar plot. Okay, as I told you before, in this lab session we have covered the following are functions, that is names, head, tail, summary, mean, variance, median, table, and the bar plot command. Now it's time to practice another exercise, and the statement of exercise, you have to create a numerical summary for height and age and compute the interquartile range for each. Then you have to compute the relative frequency distribution for gender and exercise any column, and how many males are in the sample and what portion of the sample reports being in excellent health. To create a numerical summary for height, I am using the expression summary, and then type the table name, put a dollar mark, and now I have to select the column name, that is height, and press the enter key, and you will get the summary statistics value of the height column. Now I have to repeat the same command, but this time I have to type here age instead of height and press the enter key, and you will get the numerical summary of the age column also. For calculating the interquartile range of height, simply type the following expression, that is 70 minus 64. 70 minus 64, press the enter key, and the answer is 6. And for calculating the interquartile range of age, simply type 57 minus 31. This is 57, this is 31. Press the enter key and you will get the result, that is 26. For computing the relative frequency distribution for gender and exercise any, you have to use the following expression, that is table. Type the table name, put a dollar sign, select the column name, that is gender, and divide this expression to 20,000 and press the enter key, and you will get the male and female relative frequency value. Now repeat the same command pressing the upper arrow key and remove the gender and type here exercise any and press the enter key, and you will get the relative frequency of that column too. Okay, so next question is how many males are in the sample. For finding the total number of male in the sample, use the table command. Type the table name, put the dollar sign, and now select the column name, that is gender. Press the enter key and you will get the male numbers, that is 9,569. Okay, so the last part is what portion of the sample reports being in excellent health. For finding this value, use the following expression, that is table. Type the table name, that is CDC, put a dollar sign, and then type column name, that is gender health, press the enter key, and this shows the total number count of the excellent health. And for finding the percentage value, simply divide the above expression 20,000 and press the enter key, and we have the result, that is 23.28% are the statistics value that showing the persons who have excellent health condition. Okay, so hope so this lab helps you a lot. I will see you in the second part of the lab 1.